So today we're going to practice taking the derivative of trig functions again. Make sure at the top of your paper you have filled in exactly how we find the derivative of all 6 trig functions. We can pause the video now for you to write them down. So we're going to start with number 1, and it's sine of 3x. Well, u is our 3x, so u prime is 3. So filling in our derivative, 3 cosine of 3x, and that is our y prime. I'm going to do similar for number 2. U is 3x here, so u prime is 3. So our derivative for cosine is negative u prime sine of u. Same thing for tangent. Up here, so u secant squared of 3x. Now for number 4, we have to be careful because I'm going to rewrite the original as 4 times cosine of 2x all squared. This is the shortcut for writing this. So to find the derivative, the 4 is a constant, it stays. And now we need to use the chain rule for cosine of 2x squared. So the chain rule, 2 comes to the front, and then the derivative of the inside, well, this is our u, so u prime, and then the derivative of cosine. Now look back up at our chart. So it should be negative and then sine of u. So negative. So combining my like terms, 4 times 2 times negative 2 is negative 16. Cosine of 2x, sine of 2x. Okay, so for 5, the derivative of secant is secant tangent, and minus, and the derivative of tangent is secant squared x. And now for 6, again, we have to rewrite this. We're going to need to use the chain rule. This is secant of x squared minus tangent of x squared. So using the chain rule, the derivative of the entire outside times the derivative of the inside. The derivative of secant is secant x tangent x. Now the chain rule again for tangent squared. And now I notice here, secant times secant I can combine together. And then I'm going to bring down this other piece. And I notice I have this term minus itself, so that really equals 0. Now if you remember your trig identities, secant squared minus tangent squared, that's really just 1. So now the derivative of 1 is 0. So it's easier if you use your identities sometimes than going through all of the trig work. Okay, so for number 7, we have to use the product rule. So for the product rule, secant, the derivative of secant is secant tangent. And then we have cosecant, and the derivative of cosecant is negative cosecant x cotangent x. So the product rule, we take the original first term times the derivative of the second. That's negative secant x cosecant x cotangent x plus the second function times the derivative of the first, cosecant x secant x tangent x. Now 8 is much easier if we use an identity. I'm going to rewrite that as tangent of x. So the derivative is secant squared x. Now if you didn't remember that identity, let's do number 8 with the quotient rule. So the quotient rule says the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Or, if you remember, our low d high minus high d low over low low. So now let's simplify that. This is 0. Negative times negative is positive. Well, I don't need to write this 0 plus. And I'm going to simplify this because I know it can be simplified. Cosecant squared I can write as 1 over sine squared. Cotangent squared is cosine squared divided by sine squared. But now I don't like this complex fraction, so I can multiply by the reciprocal of my denominator. And these terms equal 1. So we're left with 1 over cosine squared, which is secant squared. And that's exactly what we got back on the first problem, but much faster because we used the identity right away. But if we didn't remember that identity and we wanted to use the quotient rule, we would still get to the same answer. So now your job for the remainder of class is to do the 10 problems on the next page. Make sure your answers match the answers at the bottom.